The last time I played Bowser's Inside Story, I walked through the general process of image recognition and showed how I got my code to beat the Goomba Storm minigame to at least A rank. That was only one of Bowser's special attacks, and we're not going to stop until Broke Madame has received the best massage possible. I developed the rest of the minigames in parallel, and was originally planning on showcasing all of them in this video, but to keep the video from getting too long, I'll focus on one. That said, can we use Python to A rank Bob-omb Blitz? This minigame has you dragging Bob-ombs to be in line with Broke Madame. You have a few seconds before they run across the screen. If they're lined up, they'll explode and score you a point. Then Broke Madame moves, and you'll get new Bob-ombs. If any Bob-ombs miss, you'll get a strike. 3 strikes, and you're out. Over time, more Bob-ombs will come, eventually capping at 6. Thinking about what the program needs to do. We need to find Broke, and we need to be able to find the Bob-ombs. Then, we just need to drag the Bob-ombs so that their Y-coordinates are close enough to Broke's that it counts as a hit. This means we actually have 2 needles and 2 haystacks. Technically, we could have 1 haystack and take a picture of the whole bottom screen, but since both things we need to find are isolated to certain regions of the screen, it should be faster to have 2. So, running from my initial Bob-omb branch, we can see that both the Bob-ombs and Broke are being successfully identified. You'll notice that the Bob-ombs are being identified by the back half of their sprite. I did this because of how they form in a line. Only the frontmost Bob-omb has the whole sprite showing. So in order to identify the Bob-omb, we need to check the back half. To get it actually running, I created a loop similar to Goomba Storm, where I would get both haystacks and try to find both needles. Once I had the coordinates of Broke and the Bob-ombs, for any Bob-ombs more than 10 vertical pixels away from Broke before the scale factor, I would drag them using Pilot or GUI's mouse down, move 2, and mouse up to Broke's Y coordinate and keep the Bob-omb's X coordinate. And yeah, watching this first attempt back, the code is at least following the right flow, but it doesn't work well. I'm not sure exactly how much I understood these mistakes at the time, but there's 2 issues. Sometimes we're not finding Broke, that's why we'll occasionally draw the Bob-ombs to the top of the screen. Additionally, even when we find her, the alignment is a little bit off. By increasing Madame's haystack width, we're now finding her reliably, and by adding half the Bob-omb's sprite height, we're also aligning with her to score some points. However, it still isn't consistent. I think part of it is the mouse is moving so fast that the input isn't being registered consistently. It also doesn't always move to be in line. Sometimes it moves close, but not right. I think this is due to not always identifying the same part of the Bob-omb. And it also appears to keep trying to drag Bob-ombs that are already in line, though that could be a result of the previous 2 issues. I tried sorting the Bob-ombs by how far they were from Broke vertically, but after some testing, it didn't seem to fix the core issues, and I didn't think it was the right approach going forward. It felt like part of the problem was how well the Bob-ombs were actually being identified. If you had Bob-omb A that is almost vertically in line, but not, and Bob-omb B that gets dragged in line, such that B now overlaps A might now not get recognized, or grabbed at a funny angle and dragged slightly out of line. The solution to this was pretty simple. The Bob-ombs always line up in the same way, and their line doesn't fill the whole draggable area. If we reduce the width of the screenshot to just be the area we would find Bob-ombs, we can then drag them to be vertically in line and have an X coordinate that is outside of where we're taking screenshots. This will naturally prevent them from overlapping. This felt a lot better, though only improved the score marginally. Now that we're moving Bob-ombs outside the haystack, I realized that we can use the full sprite for our needle. I did that and increased the threshold, meaning we have to be more confident in our tempo match. Those 2 factors should make where we grab on the Bob-omb much more consistent, preventing poor alignment. Watching the replay, this works as intended. We're not misaligning anymore, and our score roughly doubled. But to get to A rank, we need a lot more, and the big issue I am currently seeing is that we have so many wasted clicks where we fail to drag the Bob-omb. This was a recurring issue throughout all of these minigames, so I was used to dealing with it. I just hadn't prioritized it until now with how many other issues I had found. I just added a sleep between when I mouse down on a Bob-omb and when I try to drag it. I experimented a little bit with how long the sleep should be, and ended up settling on 0.01 seconds. This notably still is a little too fast, as it will still miss Bob-ombs, but in my testing I found it to be the optimal value. Even missing a click here and there isn't as important when we're moving at that speed. Alright, with that last adjustment, we're now achieving A rank. And I was going to leave it at that. After all, the time window gets very tight after you reach 150. But the part of me that loves to optimize wouldn't sleep. It was gnawing at me. And there was an idea I was toying around with for a while. Why are we even trying to find the Bob-ombs at all? There's no need to search for their locations. We already know where they'll wind up. I can just hardcode the locations. This also circumvents another potential problem, since I'm not sure if the flashing the Bob-ombs do when they're low on time was impacting the template match. In hindsight, hardcoding the locations could have actually prevented a number of problems throughout the project, but I didn't need the speed until now. This actually brings me to a quote I want to go on a tangent on. It's another quote my Systems 1 professor loved. Premature optimization is the root of all evil. I'm a guy who loves to optimize code to be faster, but it's important to not go overboard. Speed is important, and in my opinion, it's very fun, but time spent optimizing is time not spent making new features or fixing other bugs. I'm writing in Python, which isn't the fastest language, but has a lot of libraries that make it fast for me to develop in, and it's fast enough for what I need. So as a general rule, you shouldn't agonize over optimizing every line of code you write. First, get it working, and measure if it's fast enough. Once you start testing it and find a performance-related issue, that's when you can go back and optimize. I've reached that point now. I'm able to A rank as is, but if I want to get a higher score, and I think that I can, it's time to optimize. Hardcoding the locations drastically reduces how much time I waste taking screenshots. Since I was trying to find images of the whole Bob-omb, I needed to take a screenshot after each drag and search again. Since I wasn't fully optimizing, I was also doing the completely unnecessary work of screenshotting Madame and searching for her between each drag. While the time it takes to do that is low, as we get past A rank, it is certainly not a negligible amount of time. Now that I'm hardcoding, I still need to take a screenshot of the Bob-ombs. That's only to see if they're there at all. I also only need to check if the first Bob-omb is there, so I can shrink the search space to the first Bob-omb's final position. If I don't see that Bob-omb, that means we haven't moved on to the next round yet, and I'll just keep checking until we see Bob-ombs loaded. Once that happens, we should look for where Broke is. I take a short pause to make sure she's moved to her new location, then I just go through the hardcode positions and drag all the Bob-ombs. I don't even bother to check how many Bob-ombs need to be dragged. I could do that even without image recognition. They always come at the same round number. But there's no penalty for doing the wasted drags when there's less than 6 Bob-ombs. Compared to the previous method, we've saved 10 screenshots and searches. This saves a lot of time, and I was able to reach roughly 400 with this approach, but it isn't consistent, and sometimes we're only barely cracking an A rank. Sometimes we're dragging Bob-ombs to Broke's last known location, which is either because we don't pause for long enough, or because the slight animation she has could throw off the template match. Either way, this can cause a strike. Also, between the sleep and maybe some other inconsistencies, we're not always fast enough to move all the Bob-ombs, which is another way that we can get our strikes. So I had one last idea, literally just now as I was writing the script. Originally, I thought that last approach was going to be my ultimate high score. But instead of having a set pause time after we know the Bob-ombs are ready, what if we just repeatedly search for Madame until she's found? How high can this version of the program get? gentlemen, we've officially maxed out the score for one of these game modes. I'm incredibly happy with this. I honestly wasn't sure during development if it was possible. I mean, I was literally writing the script thinking I was done. But once it cleared 400 with no strikes, I knew the rest was just a matter of waiting. Not only does it feel great to accomplish this, but it makes me pretty confident that at least Goomba Storm could be optimized to reach the max score as well. Thanks again for watching. If you want, recommend some other games in the comments. I'm still looking to finish Bowser's Attacks, the Bro Attacks, and Gut Check, but I'm open to new ideas. I'll see y'all in the next one.